Faults are a very important consideration in carbon dioxide storage. They can act to enhance or inhibit our ability to keep sequestered carbon dioxide safely and effectively underground. Fault seal potential depends on juxtaposition, shale gouge ratio, and a cross-fault pressure difference. Faults that act as structural traps are called fault seals. Faults that act as a migration path for fluid flow are called conduits. Juxtaposition of the lithologies on either side of the fault comes in two forms. A fault may juxtapose a reservoir against a non-reservoir. This picture shows an example of reservoir against reservoir juxtaposition in the upper left-hand corner, where two sandstone layers lie next to each other. A fault may also juxtapose a reservoir against a reservoir. This type of juxtaposition can be found in the center of the picture, where sandstone lies next to a layer of shale. Juxtaposition can trap carbon dioxide, allow it to migrate, or do both. Here, the reservoir is juxtaposed within caprock, creating a trap for carbon dioxide. In the lower part of the fault, carbon dioxide is trapped under caprock. However, the reservoirs are also juxtaposed, which allows for leakage.
Shale gouge ratio are used to estimate the clay content, which reduces the permeability and porosity along faults. Here is an example of shale. It's low permeability and low porosity rock, which is good for caprock. Here's an example of sandstone, where it is a high porosity and high permeability rock. This is a good reservoir. This graph shows that as the shale gouge ratio, or the more shale in the gouge, the better the fault will seal. Low ratios, or a gouge with higher sand content, do not seal well and are likely to make conduits. Finally, a cross-fault pressure difference is an important factor in carbon storage. High pressure difference across a fault inhibits the formation of an adequate seal, such as a shale gouge ratio that separates the higher pressured carbon dioxide reservoir from the other side of the fault. Once the buoyancy pressure is equal to or greater than the capillary entry pressure, this will cause carbon dioxide to leak because the buoyancy pressure will exceed the maximum supportable pressure.